Okay, hello everyone. So today our topic is about resistance and about Ohm's law. Okay, so let's move to the first slide, and here is about Ohm's law. Okay, so what is Ohm's law? So you can find this is a name or a scientist name, and using his name to form a law, right? So you can find here Ohm's law means that there's a resistance of a resistor equals to the potential difference across a conductor over the current through the conductor. Okay. So as I said before, like potential difference is just like a height of the river, right? Or a height difference. Like if you have a battery and then you have a switch and then you have a lamp and then you form a like a photo circuit, right? Like this way. So maybe here you can consider like this path, like here, the path through the lamp, and maybe here can consider as a very steep slope right here and a very huge stone in the center blocks the way of the river flow. Okay, so maybe here we can find we said that potential difference means height, right? And the current means or like the answer or the magnitude of the current means like the velocity of the current, right? So you can consider here, if the stone is very big, then it will block all the current, right? So maybe here the resistance is means like very big, or big. Here it just restrict the river flow to flows, right? So we can say as R is very big, that the current will decrease, right? This is the first part. And another thing you can find, if there's a block, and if you increase the height difference as like the front of the river and the lower place of the river, and you will find that height increases like the U increases, right? But their difference increases. Will also make the river flows quickly, right? So here using this way, you can find the resistance increase and will let the current decrease when voltage doesn't change, okay? And when here voltage increase or potential difference increase, that will let the answer or the current value increase, okay? So now we can form the formula that is U equals to I times R, like this way, okay? So U means the voltage and I means the current and R means the resistance, okay? So here it is. And here is an example, like if a potential difference of 6 voltage needed to make a current of 3 flow in wire, okay? So you can use the formula that U is 6 voltage, 6V, and I means 3 ampere, and the resistors equals to the 6 voltage over 3 ampere equals to 2 ohm, okay? So this is for the formula, okay? I think it's not very difficult for you. This is Ohm's law, okay? And there's, we have already talked about Ohm's law and or make a basic understanding of Ohm's law. Then let's move into next part about some factors affecting resistance, okay? So resistance is just made in the factory, right? Why resistor made by factory? So once they were made, that means their basic principle and their basic properties are like designed or they're definite, right? So how the basic physical quantities will make a difference on their resistance? So here it gives an answer. Like if you're measuring different resistors resistance, like here you're using a short thick copper wire, you'll find the resistance very low, or like it's like a stone in the center of the river and it's very small, like this way, okay? And once you become longer, thinner, and using maybe another materials like the nickel wire, rather than using a copper wire, you'll find the resistance is very big, okay? So you find there are some physical quantities that will make a difference on the physical property, like here, the length of the resistor, the cross-sectional area of the resistor, and material of the resistor, and finally, the temperature will also make a difference on the resistor, okay? So maybe for the last part, maybe for film and lamp, it's very like appeared mostly or maybe mostly influenced by the temperature. But for length, cross-sectional area, and material, it is for all the metals or all the substance, and you want to measure the resistance or you want to change the resistance, you can just change the length, cross-sectional area, and material, okay? So this is for some factors affecting resistance, okay? And then let's having a discussion of resistance and heating effect, okay? So here is a part of like talking about resistance and heating effect. Like if we're using a heating element like here, you will have to blow the wind from the machine, right? And you'll find you can just heat the resistance, right? That is because if you offer an current, and that will lead a power change, or like it has a power in the wire, like this way, okay? So we can say, like here, power equals to I squared times resistance, okay? That means it will blows a very hot heat, or like a very hot wind out of the apparatus, okay? So maybe for other materials, like here, if you keep making a current inside of this, that will make it afford heat, okay? This is for resistance and heating effect. And here are also some resistant components I want to introduce to you. Like here, the first part is the resistors, or you can also call variable resistors. So here is a resistor. Resistor just like this symbol, like maybe let's zoom in this part, like zoom in. Here, the resistor is like this way. Okay, just a rectangle in the wire, right? And the variable resistor means like here, if you just put a resistor right here, and then you draw an arrow from the bottom to the upper, okay, like this way, okay. And you can find here the arrow just turning to the right upward direction, okay. So this arrow just means like a very tiny pin. You can just to judge it to switch into different like different resistor for the resistance, okay. This is variable resistor. And another is thermistor, like here, thermistor. So thermistor is a very interesting resistor, and like it's showing like this way. And the resistor just changed with temperature changes. Like here, this is a thermistor. Okay, you can draw like this way. And when the temperature increases, that will make the resistance decreases. Okay. So in IGCSE tests, like thermistor, like light dependent resistor, or like heating resistor, like maybe many kinds of resistor, like they're just like depending on the force outside, depending on the luminous outside, depending on the temperature outside, or depending on like pressure outside, like all the resistor just has their outer physical quantities increase. Like here, temperature increases, or here, the light dependent resistor, you can draw some rays on this. Okay, draw some rays on this, and here's a resistor. Okay, but just like the sunshine, just shoot directly on the resistor like this way. Okay, so we can call this light dependent resistor. And here is just the luminous light increase that will make the resistor decreases. Okay, so here's for light dependent resistor. And another kind of resistor is called diode. Okay, so maybe we can hear mostly like we said, it's a light emitting diode, right? So that diode is a very important part in the components of the circuit. Okay, so let's have a brief understanding of diode. You can find diode is like a triangle and added with a straight line perpendicular to a triangle and formed in the wire. Okay, and just like an arrow, right? You can find this shape is like an arrow, like here is like an arrow, right? It's just pointing from left to right, okay? So it's just like an arrow that makes like a color to have its fixed direction. So for current, they're also like the water, the river flows, they can only flows from left to the right, like this way, okay? So if the water or like the current wants to flow from the right to the left, you can find here is blocked by the diode. Okay, so current cannot pass through the diode, or like here just broken like this way. Okay, so current cannot pass through the diode in different or in opposite direction. Okay, so please remind this is very important for diode property. Okay, so this is for diode. Okay, so here we have some introduction of resistance components. I'm wishing that you can make a briefly understanding of this and trying to know the difference between the resistance. Okay, okay, so here's how we can judge different resistance. Okay, so let's have a review on VIR equations, or just based on the Ohm's law. And like here, if we have a 12 ohm resistor and have potential difference of 6 voltage across it, and if we want to find the current in the resistor, you can use the Ohm's law, right? So resistor equals to U over I. So here U is 6 voltage, means the potential difference. And I we want to calculate this, and R is 12 ohm. This is for resistor, okay? So here we can say, oh, I here is equals to 6 voltage over 12 ohm. It is equals to 0.5 ampere. Okay, so we can use the Ohm's law to calculate the current right here. It's 0.5 ampere. It's a lot very difficult, right? And here is to drawing a current graph, current and potential difference graph. Like if you can judging or like changing the potential difference, changing the current, and make the division right here. And then you can calculate, okay, so here is potential difference divided by the current, okay? And then you can write down all the answers or like all the resistance after the columns right here. So here you can find they are all 5 ohm. So that means if you're drawing a current and potential difference graph, it must be a straight line. That means their gradient or like their resistance doesn't change, okay? So this is for the I and U graph, okay? So maybe in the future, we are learn how to draw a diode graph, how to draw a filament lamps IU graph. Okay, so this is future we learn this. Okay, so here's a very interesting comic figure how to show you that it is about an Ohm's law, or understanding of Ohm's law. So you can find here like a person just applying force on the string and just to try and hold very tightly to doesn't let the amper or the current to pass through the like the wire like this way. Okay, like this way. And for voltage here, it's just like people or is kicking the amper's ass, right? So you can find the amper just passes through this. So if its ohm resistance is very big, that is holding very tightly, right? The amper or the current cannot pass through very easily. But the voltage means that, oh, if you're kicking your ass, the force is very big, that the amper is passing through more quickly, right? So we can find like resistance is very big, so it means that the force is very tightly on his waist, right? And if the voltage is very big, that means the kicking ass force is very big, right? So this is for understanding of Ohm's law. So we can write down the formula U equals to IR when U is very big and I doesn't change. Sorry, and R doesn't change. That means I must be very big. And if here U is very sorry, R is very big and U doesn't change, that means I must be very small to make the total product equals to the same value. Okay. Okay, so let's move into exercise, please. Try to understand how to calculate for this problem, please. Okay. Okay, so for A, determine the term electromotive force, right? So we said before that electromotive force means that a potential difference on a cell, right? So we can just write down here potential difference across a cell. That's very difficult, right? Please remember that here is a single cell. And B, the battery is connected to the series with a variable resistor and a 30 ohm resistor. So we can draw like this graph, right? And here is a graph, and here is a resistor, and here is a variable resistor like this way. And we can draw like this, okay? And here it is that the battery is made using by 1.5 voltage cells, right? This is 1.5 voltage. So here is a graph, okay? And they produce an EMF of 7.5 volts. So here must be 5 cells, like combining series like this way, right? And here is a variable resistor, and here is a 30 ohm resistor. So you can draw the graph like this way, okay? So this is for today's lesson. I guess it's not very difficult for you, and just try to take a notes and make a totally review for this lesson, okay? So see you next time. Bye.